Artificial intelligence is the ambitious project of recreating the complex mechanisms of human cognition deep inside a machine. This pursuit began in 1956 at the Dartmouth Workshop, where John McCarthy first used the term artificial intelligence to describe the field. The goal for these early researchers was to simulate human learning and reasoning on a computer. They measured progress using the Turing test, which suggests that if a machine can produce responses indistinguishable from a human, it is performing the act of thinking. Computer science provides the tools for building these systems, but philosophy provides the definitions for what they are actually attempting to achieve. To understand if a machine is intelligent, we must first address the question of what knowledge is and what constitutes a mind. This brings us to epistemology, the study of where knowledge comes from. One major school is rationalism. Philosophers like Plato argued that knowledge comes from innate logic and reasoning, rather than from our senses. This maps to symbolic AI. These systems are built using hard-coded rules and logic trees, mathematical truths given to the machine by a programmer. The opposing school is empiricism. John Locke argued that the mind is a blank slate, and all knowledge is derived from observation and experience. Empiricism uses inductive reasoning, taking specific observations, like seeing white swans, to form a general rule that all swans are white. Modern machine learning follows this path. These systems are not fed logic. They extract their own rules by observing patterns in large datasets. These two schools of thought lead to different ways of building software. In a top-down symbolic system, data travels through predetermined logical pathways. In a bottom-up machine learning network, the system adjusts its internal connections based on data, learning its own logic. The architectures powering modern AI are built directly upon these competing theories of knowledge. This raises the question of the mind itself. Does executing these processes mean the machine is actually thinking? Functionalism suggests that mental states are defined by what they do. In this view, the mind is the software running on the brain's hardware. Functionalists define thinking as moving from input through an internal state to output. When solving math, the equation is input, memory the internal state, and the written answer the output. If a silicon processor uses this exact logic flow, the function remains identical. This is multiple realizability, the idea that reasoning can happen on a biological brain or a computer chip, as long as the function is performed. For a functionalist, a machine that processes an input to generate a correct output is performing the act of thinking. John Searle countered this with the theory of biological naturalism. Searle distinguished between syntax, the arrangement of rules and symbols, and semantics, the actual meaning of those symbols. We can see this distinction in machine translation. The algorithm maps one string of characters to another based on a set of rules. This is syntax. The machine lacks any understanding of the concepts behind the words. This missing comprehension is the semantics. A machine is a syntactical engine. It knows that one symbol triggers another, but it does not understand the reality those symbols represent. In this view, the Turing test only measures a machine's mastery at syntax. It confirms a system can calculate without providing evidence of comprehension. This leads to the concept of intentionality, the ability of a mind to have thoughts that are about objects or states of affairs in the world. This introduces the problem of qualia, the subjective, conscious experience of a mental state. David Chalmers calls this the hard problem of consciousness. When a robot observes a traffic light, it registers physical data, like light frequencies and color codes. But when a human looks, they have a subjective experience of redness, a feeling entirely separate from the data. A machine can measure every physical property of an object without ever having a subjective experience of it. Whether a machine can think is a question with different answers, depending on the philosophical framework used to judge it. If thought is defined by functionalism, the ability to process inputs into correct outputs, then machines are already performing it. But if thought requires semantics, intentionality, and qualia, then the machine is an empty processor. No matter how well an algorithm mimics human behavior, until it can bridge the gap between syntax and semantics, it functions as a fast, blind processor of symbols.